after you guys have seen a couple of these, I want you to try this one for Maclaurin series for cosine out, similar to how we did e to the x and sine x. This is the third of the ones that you should kind of have an idea of for the AP. All right, hopefully you had a chance to try it here. So we're coming up with all the derivatives over here and what they are at 0. You should have got there. So now if we fill this in, our general Taylor or Maclaurin series, since it's centered at 0, our original function here, the value is 1, so that's why we see a 1 here. 0 factorial x to the 0. Next, if we put in 1, now it's the first derivative value at 0, which is 0. 1 factorial to the first. Our next value is -1, 2 factorial squared, and so on. All these terms that have 0 in are just going to all end up being 0. So if you just write out the ones and simplify it, it ends up looking like what we got here. If you were to continue this, the next one would be -x to the 6 factorial. Next one would be plus x to the 8th, 8 factorial, and so on. Here is the pattern. So seeing this one, you can see only the even powers on this one with the matching factorial on the bottom. So how could we write this out as a general series? It is alternating again, so let's get our alternating part in there. This one would be -1 to the n, because the first one is positive 1. So if we put 0 in right now, it'd just be, this should equal +1. And then it would be x, but we only want the even ones. So like we did last time, I think if we just leave this one at 2n without the 1, it should give it to us. So if we put 0 in there, it'd be x to the 0 like we want. If we put 1 in, the next number, 2 times 1 is 2, yep. If we put 3 in, sorry, 2 in, we get 2 times 2 is 4, 3 in is 6, and so on. So then our matching factorial should be the same thing, 2n factorial. So if you came up with that, nice job. So that's the third one you should know for the AP test, that the series for cosine ends up being what we just came up with there. The main thing you'd probably want to remember is that cosine is the even powers of x alternating through. Okay, let's look at that on that decimals calculator again. So if you go to decimals, let's go with cosine now. So if you do cosine, if you go through these, there's just the constant term, doesn't change. Every other one's going to change it here. There's our adding our next term. I'm going to skip one. There's our adding the fourth term. So that's the x to the fourth over 4 factorial. There's the sixth one. You can see it's getting closer and closer approximations each time. So that's what a Taylor series approximates it, especially right around 0. It's a very good approximation. All right, last thing we're going to do now is use one of these to find out a new function. So here they want, what's the Maclaurin series for f of x equals x cosine x? Now, we don't have to, on one like this, we don't have to go through that whole thing again. Now, we can be a little bit smarter about this. So we know cosine, the one we just found is the even one. It's going to be 1, it alternates, I forgot, alternates here, 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and it keeps going. So if we wanted x cosine x, what that's going to do is times all these. Then if we got a new x on this side, what we can do is take this series and times each term then by x, and it should give us this new series. So what we're going to do is go through and multiply each of these terms now by an additional x, and that should be the new one for this one. So x cosine x should give us the one of x, because 1 times x is x. We're distributing now. Next one, if we take x times x squared, that's going to be x cubed over 2 factorial. Next one would be x to the 5th over 4 factorial. The next one, if we times by x, would be minus x to the 7th over 6 factorial, and so on. So now, if they were just looking for that on the AP test, we would have that. Maybe sometimes they have the answer like this. If they wanted that general term, now you'd have to match it or come up with what's the series for this. So let's see if we can do that. So if we start at 0 and go to infinity here, what's this one going to be? It is alternating, and we want the first one positive, so we can get that by doing -1 to the n. The only the odd powers of x are there, starting with the first one. So we want x to the, if we want it odd, we want to add 1 on here. So 2x plus 1. So if we put 0 in right now, the first one would be x to the first. On bottom, though, that we only got the even powers. So on this one, then we would have 2n factorial. So the first one would be 0. If we put 1 in there, you can get it and so on. So you could test these out by just trying out some of the numbers in there, and it should work. So that would be our general series for x cosine x. So that infinite series would be the one we'd want there. So once you know some of these basic ones, you can find other ones more simply that involve cosine, sine, or the exponential e to the x.